we want us to have a look at just some basics in manufacturing, and we'll be starting with the oral solid dosage forms. And today we'll have some bias towards the tableting. So in tableting, after you've undertaken all pre-formulation studies, and you have gone as far as selecting the excipients, actual excipients that you are going to to use in the formulation. What we have is what we can refer to as a general flow chart of how things are going to be moving, or what steps you are going to be undertaking. So here I have a flow chart that is telling you how you are going to move from one step to another until you get to packaging of the product that you'll have made. So here we see that you start with the active pharmaceutical ingredient, which is the API. And from there, we undertake the process that is referred to as screening. In screening, we want to ensure that all the materials that we are using have got a uniform particle size distribution. So we select a mesh screen through which we force these materials that we have, and then those materials which will remain on the screen will need to undergo particle size reduction, and then you pass them through the same screen as well. And then down there, you've got the binder. If you are going to be using a binder, or sometimes you might be forced to use more than one binder. If you are going to be using, remember when we looked at binders, we said binders can either be added as a dry binder or as a solution. If you are going to add as a solution, you then need to prepare a binder solution. Then you are going to mix the materials that you screened, mixing of granulation blend, together with the binder solution. This process is referred to as granulation, and we'll talk about this a bit more. From granulation, because you have added a solution, then you need to go to the next stage of drying the granules that you will have produced. Here, under drying, we take care of a number of things. We see that we have LOD, which refers to limit of drying. You can't just keep on drying. There's a limit to which you can dry the sample. And this is quite important, because if you over dry, then you might destroy the material. Then from the drying, we have what is referred to as the milling, which is simply particle size reduction. So for granules that might be of larger size, you might reduce the particle size so that you again try to reach uniform particle size reduction. Then you also have other materials that can be added, the disintegrant. This also need to be screened, and then you mix with the milled material here. This will be referred to as the initial blending. And then after that, you can then add as a final excipient the lubricant. Remember, we had indicated earlier again that the lubricant is added in the final step to avoid overmixing with other excipients, which can have a negative impact on the disintegration and dissolution characteristics of the tablet. So after you've got the final blend, then you go on and put the materials into a tableting machine. for you to undertake compression. So once you compress, you produce the tablets, and you can assess the tablets for weight, hardness, and friability. So we'll again have a look at how you assess the characteristics of the tablets upon production or compression. This will refer to a case where you want to produce uncoated tablets. Okay, but if you are going to proceed and produce coating tablets, then you go to the next stage of preparing solvent fume coating agent. You select and you prepare the coating solution, and then you coat the tablets. And then once you coat, again, there's going to be a stage of assessing the quality of the coating tablets. Then you can go on to packaging and labeling. So if you look at this flow chart, it has highlighted a number of pharmaceutical unit processes which you need to have a look at in the manufacturing process. So we see here that if you were to highlight the pharmaceutical unit processes, you are having a look at mixing being one of them as a pharmaceutical unit process. You also have granulation. You also have drying. You also have the milling, or which can be referred to as comminution or particle size reduction. Then you also have issues of coating. So these are some of the very important pharmaceutical unit processes that are involved in the manufacturing of tablets. So this flowchart, in essence, is a summary of all the processes that are likely to be undertaken during the manufacturing of tableting. I need to move to the next step. Just a minute. My computer is misbehaving a bit. Okay, so this is what we have. What are some of the manufacturing methods that are available? So broadly, you can categorize manufacturing methods into two methods. You have the granulation method and the direct compression method. The granulation method is further subdivided into wet granulation and dry granulation. So in this table, I have a number of steps that are involved in each of these methods. And we see that as we move from wet granulation to dry granulation and direct compression, the number of steps involved is decreasing. So if you have a look at direct compression, in direct compression, we see that we are only concerned with 3 steps. First, you have the milling or screening. You reduce the particle size, you screen the materials to ensure they've got the uniform particle size distribution, and then you go on to blend or mix the materials. Once you are satisfied with the degree of mixing that you have achieved, you take the blend into the tableting machine for compression. So this is a very short process for manufacturing. And this is always the first method to go to when you are embarking on manufacturing of tablets. only if you get to see that the flow characteristics of the powder blends you have are quite poor, then that's when you consider granulation. Again, here you've got dry granulation. Dry in the sense that here we do not have any solvents that are added, okay? So you have the screening that you get to have, and then you have pre-blending. You combine or you mix the materials that you have, and then you produce, we'll look at this again later, depending on the method that you are using of dry granulation, you can have what is called slugging or roller compaction, and then from there you go to dry screening. People making noise. Okay. Yeah, so after production of a slug or a compaction, you go to dry screening. Again, you pass the material into a mesh screen, and then you add a lubricant and then blend together with the granules, and then you proceed to compaction. When you go to wet granulation, we see here that there's addition of a binder, okay? The binder is added in form of a solution. As a result, you are going to have a wet mass. That wet mass is forced through a screen, and then you are going to produce wet granules. These wet granules will then need to be dried. Once you dry them, they'll again need to be screened. And then from screening of granules, you can add a lubricant, or you also add a disintegrant if that is necessary. So we see that here, again, a number of pharmaceutical unit processes are coming out very strongly, indicating that there's need for you to understand the principles of these pharmaceutical unit processes. Again, we see here milling or particle size reduction coming out. Again, we have seen blending coming out very strongly, which is mixing. Again, we've seen that there's a principle, the principles of drying are coming out. Drying, screening, or drying of the wet granules. This means that you must know how the drying process is undertaken. Again, we have seen that there's also an issue of granulation as another pharmaceutical unit process. Of course, in all of them, the final step is the compression step. So you need to also understand how compression takes place. So if you have a look at this, I've always advised that really you are not going to understand manufacturing if you do not understand the pharmaceutical unit processes. So at this point, I would suggest that all of you need to have a look at the principles that are involved in all these pharmaceutical unit processes. So you need to have a look at particle size reduction. You need to have a look at mixing. You need to have a look at drying. You also need to have a look at granulation and so on. So what I've done is that I'm going to post some slides on Moodle, which you are going to go back to. So I don't know if you can see my screen now. Can someone confirm you can see the screen?
No, sir, we can't see.
We can now see.
Okay. So I'm going to upload these notes on Moodle. These are slides for pharmaceutical unit processes. Just for you to have a look at the principles of mixing. So these slides have got the key important things that you have to look at. You look at the importance of mixing. Then you also have a look at objectives of mixing. And then the slides also have got equipment that is used for mixing. Okay, so each equipment that is highlighted, you've got the name of the equipment, and then you also have the principle of operation. How does that equipment operates? What are the advantages and disadvantages associated with that equipment? And how can you overcome the challenges associated with it, using such a machine? So the slides on mixing, quite many, I must say, they're about 106 only. But this is for your revision because the understanding is that you should have done, or you did, pharmaceutical unit processes when you were in second year. So these slides are coming from second year, but you need to remind yourself of the principles that are associated with these techniques before you can adequately understand the manufacturing basics. Then I've also included one other important is also comminution. So comminution is a particle size reduction process. I've also included it amongst the unit processes that you need to have a look at. You need to revise this. Again, it is following the same pattern. You have the factors that affect particle size reduction, the mechanisms of particle size reduction, and then it goes on to talk about the equipment that are available, or the methods that are available for particle size reduction, for example, cutting methods. And then when you have an equipment, there is the principle of operation. How does it operate? And then we give examples of such equipment. For example, you've got the cutter mill and so on. So it proceeds in that manner, okay? So particle size reduction is another unit process you need to revise. Then lastly, I've also included the drying. So drying methods, another very important pharmaceutical unit process. So again, we've introduced what it is, and then we've gone on to have a look at the drying of wet solids. We have a look at a number of things in drying, moisture content of wet solids and so on. So we have a lot of issues to discuss under drying, and then we go on to have a look at the types of drying methods that you need to, that are available to you, and the consideration points. How do you select a certain drying method? Okay, and then from there you get to see that you then have a look at the different types of equipment available. So here, things as a fluidized bed dryer, pan drying, and so on are found under drying here. This is the biggest unit. This one has got 124 slides. So what I'm expecting is that from today onwards, you take time and revise these pharmaceutical unit processes and ensure that you understand the principles. It's very difficult for you to appreciate the manufacturing aspects if you miss these pharmaceutical unit processes. Okay, and since you've been advised to revise this, we expect that you take time to do so. And also what you must know is that it's practically impossible to assess your understanding of manufacturing methods without us assessing your understanding of the pharmaceutical unit processes. So in short, I'm saying I'll be able to ask you questions dealing with mixing, drying, and particle size reduction at this stage. So you have to ensure that you take time to revise those principles. Okay. So those you find them on Moodle next time you log in. So these are the methods of manufacturing that are available. We can have a look at the advantages of each of these methods. So what's good about these methods? So we start from the direct compression. We see that here you've got fewer processing steps. In total, we only have 3 steps. So we see that because of that, you have reduced processing time. Okay, and whatever you do, we know that time is money. So processing time is reduced. You can produce more batches within a short period of time. Processing without moisture and heat in direct compression, we don't add any liquids, and so we see that you remove certain issues such as drying. So you don't involve application of heat or moisture. So as a result, you have fewer stability problems. Okay, you have eliminated the use of heat as well as the use of moisture. So you have fewer stability issues. Then you rapid and most direct method of tablet compression. So it's quite quick. And as I indicated, it's the first go-to method. Then changes in dissolution, less likely on aging since there are less formulation variables. Okay, if you've got fewer formulation variables involved, then you are likely to experience fewer changes in the way the drug delivery system is going to behave with time. If you look at dry granulation, again, in granulation, we are looking at producing granules. Granules are spherical particles. These spherical particles have got good flow characteristics. So in circumstances where you have determined that the angle of ripples is way bigger, implying that the flow characteristics are poor, you can produce granules. So you can use dry granules, dry granulation method. You are going to have improved flow characteristics, improved uniformity of powder density, and also improved cohesion during compression. Because you have these particles which are already brought together by either compaction or slugging. Then granulation with addition of the liquid. This is why it's called dry granulation. So as a result, this is advantageous, particularly for drug substances which could be sensitive to moisture. Then you've got the wet granulation, which really in most cases we consider as the last to go to method. If you see that the flow characteristics are really bad, then you need to consider wet granulation, okay? So in here, you add a solvent, and then you are going to produce the spherical particles. It's been shown to have to produce highly spherical granules. As a result, there is a huge increase in the flow characteristics. There is also uniform distribution of the API and the other excipients such as color. So you have improved content uniformity here. As far as the content uniformity is concerned, this appears to be the best method to give you dosage forms with a good content uniformity. So in cases where you've got problems achieving content uniformity, you should use wet granulation. And some examples include those cases where you might be using low dose drug. So in such cases, it's very difficult to achieve content uniformity. So you can use wet granulation. Good for bulky powders, less dust and environmental contaminations. Also, if you are dealing with the hazardous materials which produce dust, then you must use wet granulation, because addition of a solvent prevents the generation of dust, so you can avoid environmental contamination. Lower pressure, lower compression pressure. We see here that once you add the solvent, it's easy to have the powders stick together. As a result, during tableting, you only need to apply a lower compression force. That will allow for less wear and tear on tooling. So your equipment is likely to last longer. The methods also have got a number of disadvantages. In wet granulation, because of the large number of processing steps, we see that it becomes a tedious process, okay? You are using more equipment, so you must have all this equipment which must be properly functional at all times and calibrated at all times. So there's too many steps involved. Wetting and drying stages are time consuming. So inevitably we see that wet granulation consumes a lot of time. And as a result, the products manufactured from here are expected to be more expensive compared to those products manufactured using dry granulation and direct compression. There's also greater possibility of cross-contamination. When you have too many steps, there's high chance that someone might miss a step, or they might forget to ensure that they clean up before they embark on another step. So high chances of cross-contamination. In dry granulation, possible overcompaction of slugs. You can overcompact. If you overcompact, you can reduce the rate of dissolution. There's also a possibility of particle size in segregation. This is a case where particles separate depending on the density of the particles present. Then direct compression, here you've got possibility of lot-to-lot variations due to differences in particle size, density, flowability, and moisture content. Remember here, all we are doing is put the particles together and ensure that you achieve good blending, and then you go on to compression. So that can lead to variations from batch to batch. Higher risk of content uniformity failure in low dose products. Here we had indicated it's very difficult if you are using low doses to achieve content uniformity. That's why we go to wet granulation. Lack of moisture can create static charges that can result in unblending. Again, creation of static electricity during blending is one of the setbacks that we get to see a lot when you have dry powders. So that static electricity, not only does it pose a safety concern, it can also result in unblending or separation of the blended materials. Then differences in particle size and density between API and excipient can result in unblending in the hopper. So once you put into a tableting machine, there could be that separation of the API and the excipient because of the differences in the particle size density. Okay. So in general, we see that there are about 1, 2, 3, 4, 5, 6, 7, 8 steps that you have to undertake in manufacturing. Okay, so you start from dispensing, then you go to milling, then you go to blending, then there's granulation, then there's drying, then compression, and then coating, and then you do the packaging. So we'll start looking at all these steps one by one and have a look at some of the things that you look for. Ideally, what you find in a manufacturing setup is that all these steps are going to have what we refer to as standard operating procedures. So these standard operating procedures are step-by-step illustration or description of what you must do when you are undertaking a certain process. So each process will have all these steps, and whoever is undertaking those steps will have to, undertaking that process, will have to follow the steps, and there should be no deviation from those steps. If you deviate, you must validate that process again and revise the standard operating procedure. So you see that you simply follow those steps as indicated. Okay, we are running out of time, so once it cuts, please just log in again so that we resume the lecture. We are getting cut just now, and I would like to start when we come back. In a typical sense, when we talk about dispensing, we are applying the same basic principles of dispensing that you have already looked at in pharmacy practice. So in dispensing, we are taking out of the storage room the materials, raw materials that are required for manufacturing. So during the dispensing, you are going to receive a request from the manufacturing section. And you then be required in a way you can think of it as having received a prescription. So in that prescription or request, you are going to have a description of the materials that are required and the actual quantities that you need to issue out. So we see that everything starts from here. If you are going to manufacture a good product or good drug delivery system, everything starts from here. So this is one of the most critical steps in the manufacturing setup. You can either have manual weighing or automated weighing. In manual weighing, obviously, as the name suggests, you'll be taking the samples and then weigh them manually on a scale. Okay, you could get assistance. There could be material lifting assistance like vacuum transfer and bag filters and so on to protect you and also protect or prevent cross-contamination. Or the weighing could be automated, and all you have to be there to do is be there, ensure that the machines, the weighing scales are calibrated, and you take note of how much of the sample is being taken. This is obviously on a large scale more appropriate in that you might not manage to manually weigh all the materials that are required. That's why these days you find in pharmaceutical industries, they are using robots as well to undertake some of these processes. So what are some of the issues that you must pay attention to during the dispensing process? Number one, you've got to ensure that there is no dust, okay, in the environment. So you must control the dust. This means that the process must be undertaken in an environment that is going to contain dust. So we use what are referred to as laminar flow boards for this process. I'm getting feedback. Please ensure you mute. Each one of you needs to be on mute. Okay, so control of dust is important, and then you've got weighing accuracy. As indicated, the quality of the product will be dictated starting from the initial step. So ensure that your weighing is accurate at all points, because if you don't, you can either cause underdosing or overdosing in those drug delivery systems. Then multiple lots of active ingredients with different assays, moisture and residual solvent content. When you go to pick out the active ingredient, you must ensure that you are aware of the differences in assays or moisture be available for that API. Okay, so you can't mix batches of APIs which might have different assays or moisture content. You must be consistent throughout, ensure that you take out batch for a same for a particular manufacturing process. Then you also have to ensure that there is no contamination. Cross-contamination should be avoided at all times. That will mean every time you are dispensing, you must use clean dispensing materials. You must clean up the surfaces in the laminar flow to ensure that everything is cleaned up before you begin to weigh another material. That will make sure that you avoid cross-contamination. So ideally, what you are going to have is something like that in your dispensing area. You have what is referred to as a raw material dispensing record. So the key things that you see, this is part of the SOP. So you have your API, you could have excipient 1 up to excipient 5. This could be maybe a diluent, or this could be another diluent, or combination of 2 diluents. So then that one could be a binder, and then you can have a disintegrant, and then you can have a lubricant, depending on the formulation that you are dealing with. So you see in the record that what you have, you pay attention to the raw material batch number and ensure that this is indicated at all times. So you pick the material, you weigh, you indicate the quantity, you indicate the batch number, and obviously you indicate the gross weight and the tare weight. We know these are principles of weighing. Before you put the material on the scale, you tare and take note of the weight that you have. Some scales might not be tared to 0, so you take note of that, and then you put the material, and then you subtract in between the two, and then you get the net weight. And then, most importantly, we want to know at all times who is doing what. And for quality assurance purposes, there should be someone else to check what has been done. Okay, so you are going to indicate weighed by, you indicate your name, and then there should be another person who's observing, who's going to take note of what has been done. So that's the person who's going to sign here as checked, as the person who checked, and then you indicate the date. The whole idea of doing this is that we want to keep track of who is responsible for whatever process. Okay, so if we get to have problems with the product after manufacturing, we begin to see if we can trace where the problem is coming from. Okay, if there is contamination, we need to know who weighed and who checked and when was this done. Okay, because that will also indicate the batch number that could be talked, could be in question. So you do the same for all the excipients, and then you keep this record. Okay, so the copy will have to be sent to the people who made the request, and also you leave a copy for record keeping. Then the next step is referred to as milling or screening. Again, here, the principle is that mixing or blending is more uniform if ingredients are of similar size. So this is why we want to embark on particle size reduction and also screening. Why you do it is that particle size reduction can result in increased surface area, and you may then enhance the rate of dissolution. Okay. There is improved content uniformity due to increased number of particles per unit weight. Okay, so if you've got smaller particles, these are likely to exist in almost all proportions as compared to if you've got larger particle sizes. There is also enhanced flow properties of the raw materials. You have screened, you have ensured that they are of the same or similar particle size range. So the flow characteristics are likely to be improved. Then uniformly sized wet granules promotes uniform drying. This is one aspect that you also see during your revision. Different particle sizes who have different rates of drying. Okay, so that might present a challenge in manufacturing. So instead, what you prefer is for you to have uniformly sized granules or particles. These are going to dry at the same time. So you'll be able to predict the time it is going to take for you to dry a certain material. Then what are some of the equipment that are used? Again, you get a lot more examples and principles of operation as you revise the principles of particle size reduction. So you've got the fluid energy mill, bore mill, hammer mill, and cutting mill. Some of the problems associated with this stage, the possible change in polymorphic form, okay? As you reduce the particle size, you can have a transition from one polymorphic form to another. We did talk about polymorphism and preformulation. Then an increase in surface area may promote the absorption of air, which may inhibit wetting of the drug and could be a limiting factor in the solution rate. So whilst we understand that if you increase the surface area, you might increase the dissolution, there's also a possibility that interaction between the particles and air might increase. And that means that for wetting to take place, that air will need to be displaced from that interface. So that can present a challenge in dissolution. So when it comes to the issue of milling and screening, just as in dispensing, you are also going to have a standard operating procedure, which is going to be telling you what you need to do and what information you need to record. So for example, here you've got manufacturing instructions in screening. So here you are advised, for example, use the API, indicate the amount that you weighed and the excipient and amount, pass through number 40 screen of vibratory sifter and collect the material in double polyethylene lined container. Okay, so they are simply giving you the instructions. So combine excipient, take excipients, excipient 1 and API, put them on the mesh screen of this particular size, and then you sieve, and then you collect the material in the double polyethylene lined container. Then the next steps, you go on to pick excipient 2 and excipient 3 in their respective quantities, and then you are advised to pass these into a particular mesh screen of a particular size. Again, you collect the samples. So again, here we see that there's key information that you need to take care of. So we see that you must indicate the time when you start, okay, the screening process, the time when you finish the screening process. Again, we want to know who's performing that process and who's verifying what this individual is performing throughout the process. So the idea again here is the aspect of time is we want to know how long does it take to manufacture a product from dispensing all the way up to the time you get to have the product. So we want to keep the record and know the time. Okay, this will help in the improvement of the efficiency of the process. So if one individual takes 5 minutes, another person comes in and starts taking 1 hour, then we know that there should be a problem somewhere, and we must rectify that. And then you have blending or mixing. Okay, so we've moved from dispensing. The people in the dispensary dispenses the raw materials that are required, and they record, and everything is verified. Then those materials are taken to milling and screening for us to ensure that we've got uniform particle size distribution. And then from there, we take them to blending. Okay, a note here is that blending is the most difficult operation in manufacturing process. Since perfect homogeneity is practically impossible due to differences in size, shape, and density of the particles. So this is by far the most difficult operation, and also a very important operation. Okay, the quality of the product that you are going to have at the end highly depends on the blending operation. Why you need to do it? For you to achieve optimum mixing of different ingredients in powders or granules at pre-granulation or post-granulation stages of tableting manufacturing. Obviously, the idea is that you want to have all the excipients and the API uniformly distributed. Okay. Why you should have API uniformly distributed? You want to avoid a scenario where one tablet has got a higher amount of API compared to the other, and excipients also likewise. So this is a very important aspect. The equipment that you use, there's a wide variety of equipment. Again, as you read through the slides that are posted on mixing, you find this equipment, and then there's also the description of principle of operation, how they operate. And then the problems that you are likely to encounter, the segregation, possible overmixing of lubricant, blend uniformity or content uniformity issues. So these are the things that we are looking out for. We have to ensure that segregation doesn't happen either during blending or during tableting. Possible overmixing, you want to ensure that the mixing of lubricant is well timed. We have already talked about the disadvantages of overmixing with the lubricant. And then blend uniformity. Ensure that there is uniformity, the active ingredient is uniformly distributed within the powder blend. This has got an impact on the content uniformity of the tablets or the dosage form that you are going to manufacture. Okay. And then the next stage is after the blending, you undertake the granulation process. That is if you are looking at the granulation method of manufacture. If you are looking at direct compression, the moment you are done with blending and you are satisfied with the blend uniformity, you proceed to compression. Take the powder blend and start producing the tablets. But if you need to improve on the flow characteristics, then you undertake the process of granulation. Okay, the principle is size enlargement process that converts small particles into physically stronger and larger agglomerates. Okay, so why you do it? You want to provide homogeneity of drug distribution. There's also improvement of flow, compressibility, and hardness of the tablets. Again, there's available equipment, the problems associated, there's loss of material during various stages, multiple processing steps. Once you have a lot of steps, you have to ensure that you validate all the steps, and it's very difficult if you've got multiple processing steps to validate and control the processes. So incompatibility between formulation components is aggravated because you're bringing these materials together for a prolonged time. Again, here, let me see what is next. Okay, so maybe I could briefly talk about granulation a bit more, and I'll also post these notes on your just need to find the other slides. Yeah. Can anyone confirm that you can see the slides on granulation? Anyone?
Not yet, sir.
Anything yet?
We can now see.
Okay, thank you. So in granulation, which is another pharmaceutical unit process, what we are looking at is that just a minute. Yeah. In granulation, this is the process which primary powder particles are made to adhere to form larger multiple entities called granules. So ideally, pharmaceutical granules range between 0.2 and 4 millimeters. The size is going to be dependent on what you want to use them, the granules for. So in the majority of cases, these are converted into tablets, or you can simply pack them into capsules. When granules be made as intermediate product, we see that they have a typical range of 0.2 to about 0.5, much smaller. But if you are going to use them as a dosage unit in their own right, then you can make them bigger to go as high as 4 millimeters. Okay. So granulation normally commences after initial dry mixing of the necessary powder as indicated. After blending, then you can go on to undertake the granulation process. Again, what you are trying to achieve is that before, ensure that there is that blending so that you've got uniform distribution of which ingredient through the mix. After granulation, the granules will either be packed, used as a dosage form, or they may be mixed with other excipients prior to tablet compaction. Again, we have already mentioned this. So there are various reasons as to why you'd want to undertake the process of granulation. Number one, to prevent segregation of the constituents of the powder mix. Okay, we've seen that one of the biggest issues that is there with the mixing particles is segregation. So to prevent segregation, you can convert the powders into granules. There will be no segregation because the granules are going to have a uniform particle size and density. Then you also embark on improving flow properties because you have spherical particles. The flow characteristics are going to be improved. Then there's also an aspect of improving the compaction characteristics of the mix. Okay, once you have already bound materials, these are easy to put together during the process of manufacturing. As a result, easy compaction is going to result in you using less force when compressing. The other reasons that someone might embark on granulation is that they reduce the hazard associated with the mixing of toxic materials and generation of toxic dust. Okay, I mentioned this earlier as well. So if the materials that you are mixing are toxic and the dust might be harmful, then granulation is one way to do that. Okay. Materials which are slightly hygroscopic may adhere and form a cake if stored as a powder. Okay, so if you store materials as a powder and then this powder is capable of absorbing moisture, it's going to form a cake, and then it will be difficult to use that. So to prevent this, you can convert the powder into granules. Okay. Then granules, being denser than parent powder mix, they occupy less volume per unit weight. Okay, so it's the material as granules compared to powders. So for storage purposes, you can convert the powders into granules. Those will be other reasons why you'd want to embark on granulation. There are two methods of granulation. You've got the dry granulation and the wet granulation. In dry granulation, as the name suggests here, we don't involve any solvents. Okay, so there are two main processes in dry granulation. You can either produce a large tablet using a tableting press. So you simply take the powders and produce a large tablet using a tableting machine. That large tablet referred to as a slag. And this process of manufacturing granules is going to be referred to as slagging. So once you've got the tablet, you can then embark on milling or particle size reduction of this large slag. Okay. Then the second option you have is that you can squeeze the powder in between two rollers. Okay. So you've got two rollers, and then you put the powder in between and compress. Okay. So you produce a sheet of material. So this process is referred to as roller compaction. So the two methods for dry granulation are slagging and roller compaction. So in both of these cases, the products that you produce are broken using a suitable milling technique to produce the granular material, which is then sieved to separate the desired size fraction. The unused fine materials can then be reworked and then you can produce. So if you produce fine materials from either slugging or roller compaction, you can take back that fine material, you can compact so that you avoid wastage, okay? So this method works well after wet granulation or those which are sensitive to moisture, okay? So if a drug is sensitive to moisture, you use, but you need to produce granules, then you can use dry granulation. And then there is wet granulation, which involve wet massing. Obviously, here we are adding a solvent, okay? So the fluid contains solvent, which must be volatile. So whatever you do, ensure that the fluid or the solvent that you add or to form a granulation fluid must be volatile so that it can be removed by drying. Also, it needs to be non-toxic. Okay, typical liquids that are used in wet granulation include water, ethanol, and isopropanol. These can either be used alone or in combination with each other. So the granulation liquid may be used alone or more usually as a solvent-contained dissolved adhesive, which we referred to as a binder aid. Remember, under binders, we had indicated that you can either add it as a solid, dry, or as a solution. So you add a binder to this solvent to form a granulation fluid. Water is the most commonly used for economical and ecological reasons. In water, you can easily find water, and also it is environmental friendly. Its disadvantage is that it may adversely affect drug stability. So for drug undergo hydrolysis, it might not be a good solvent to use. And also you need to apply heat once you use water as a solvent for it to evaporate. So that means that might also affect the stability of the product to dry. Okay. But its primary advantage is that it's non-flammable. Which means that flame-proof equipment needed. Organic solvents are used when water-sensitive drugs are processed. So for drugs that are sensitive to water, you can use organic solvents. Also, these evaporate very quickly, and you can have shorter drying times because of their rapid evaporation. So in most cases, we see that we can strike a balance here. You can combine either water and organic solvents for you to cut down on the drying time. So you reduce the amount of water that you use in the process. Okay, so those are the brief basics about granulation. Those are the things I'd like you to know. The slides on granulation go on. You can have a look at mechanisms of granule formation. I don't think it's important for you to know this at this stage, but I've put there for your own reading mechanisms of granule formation, how granules are formed. The first step is nucleation, which basically talks about formation of a nucleus. And then once you've got the nucleus, more particles can be added to that. And so you've got the transition stage. The nuclei can grow in a number of ways, which we have described there. And then after that, there's, as you add more particles, the ball grows, there's ball growth. So there's an increase in the granule size. And all these are illustrated in that slide. But at the end here, this is what I have. Pharmaceutical granulation equipment. So this is going to be this week. Are you able to see the slides? Just confirm.
Yes, sir.
Yes, sir.
Yes.
So for this week, what I've been doing is that we divide the class into 1, 2, 3, 4, 5, 6, 7, 8 groups. And then these 8 groups, they go and do this assignment. So we are looking at, the question is, there are people joining, so they are disturbing me. So discuss the following granulation equipment processes with special emphasis on the following: A, principle of operation; B, advantages and disadvantages; and C, specific applications. And then you've got group A to talk about shear granulators, and then we have group B to talk about high-speed mixer or granulators, and then we've got fluidized bed granulators, and then we've got spray dryers, spheronizers and pelletizers, extrusion and spheronization, rotor granulation, sluggers and roller compactors. So every year what happens is that students will then come and present, and each group member will have to say something during those presentations. And then the groups are given marks. Grading is done both by the peers, so the fellow students help in grading, as well as the lecturer grades. And then you get the average. And this goes on as part of the continuous assessment. We are looking at, you have a look at the equipment that is used. All these are part of the assignment. And then the problems associated with granulation. There's loss of material during the various stages of processing. There's multiple processing steps, and so validation and control difficult, and incompatibility between the components is also difficult. Is also another problem that you find. Then the manufacturing instructions during blending and granulation, again, this will also come as an SOP. So whilst you know that you have to undertake blending and granulation, you are going to be provided with standard operating procedures, step by step, for you to follow. So here we've got mixing SOP, granulation SOP, and this could be numbered. I keep having people joining. Okay, so again, the instructions would tell you exactly what to do. For example, load the material from 1.1, which were the initial materials we were looking at earlier, into a granulator. And then you might be advised to add the next excipient, mix for 5 minutes with following settings. Again, you look at the granulator. Different settings of the granulator are going to present with granules with different characteristics. So depending on a product you are looking at, the SOP will guide you as to how you must set your granulator. Okay. And then it tells you spray purified water into the contents of the granulator. Obviously, that's in a case where water is being used as the granulating solvent. And then spray until purified water is sprayed. Again, in all these processes, the time you are going to start and the time you are going to end will have to be indicated. Again, you find that the granulation processes, this process will have been developed and validated. So it actually tells you that once you start this granulation process, it must be done for example, 5 minutes or 10 minutes or so. So when you start, you must indicate the time, and the time you end must be indicated. This will be a way of validating that you are following the time or the duration that is required for that process. Then again, whoever is performing and whoever is verifying and the dates on which these processes are being undertaken should be indicated. Manufacturing instructions in wet milling, again, the same thing that we are talking about. In wet milling, we are referring to reduction of particle size. In wet milling, it means you are now dealing with the wet mass. So after you've added the solvent, you are going to come up with a wet mass. So that mass must then be reduced into smaller particles. So this is what we are referring to as wet milling. So you pass the wet mass through a screen of a mouth mill. So while as you pass through the screen, this screen will also have different, a number of knives, and will be rotating at a predetermined speed, so that you can reduce those particle sizes, the particle size of the wet mass. And then you collect the wet particles in a fluidized bed dryer. Okay, so we know that you've moved from granulation, milling, wet milling, you've got the wet granules. The next step, you have to ensure that it goes to drying. So you collect into a fluidized bed dryer. Again, the time, start and end, and who's performing and who's verifying should also be indicated. So after you have collected the wet granules, you go on and embark on the drying process. The purpose of the drying is to reduce the moisture level of wet granules. We know that if there is too much moisture, this can enhance deterioration of the product, and also just the handling of the product becomes problematic. Okay, so to keep the why you do it is to keep the residual moisture low enough to prevent product deterioration, and also ensure there is free flowing properties. If there is too much moisture, the flow characteristics are going to be affected. So, and then you've got the different equipment available here. And we also know that depending on the equipment you use, you can get specific characteristics of the dried materials. All this information, you will find it in the slides, which I'm going to post under dry. Some of the problems associated with the drying process is that you can have over drying, which we refer to as bone dry. When you have over drying, that also becomes problematic in handling of the materials. The materials won't easily stick together, so compression forces will need to be increased. That can result in wear and tear of the tools that you are using. There's also a production of excess fines during drying. It's also a possible fire hazard, okay? So accidental fires can be generated during the drying process. So again, even drying is going to present with SOP. Okay, so it will tell you on the equipment, fluidized bed dryer. You are supposed to set the fluidized bed dryer to specified or validated conditions. And if you look at the fluidized bed dryer, the key parameters are the inlet temperature, what's the temperature of the air that is being introduced into the dryer, and at what pressure, and also the duration of drying. And then it also tells you there the limit of drying. You want a certain amount of moisture to be present. So they'll give you a range, 1.0 to 2.5% moisture content will be all right. So you have to indicate once you are dealing with a specific material, what the drying loss on limit of drying is supposed to be. And then again, everything else here also remains the same. The time you start, the end time, and who is going to be performing the activity and who will be the verifier. Manufacturing instruction, size reduction and blending. Again, here, the same thing has to be, you have to consider the settings of the equipment that you are going to use for particle size reduction, and also the blending. What mixing equipment are you going to be using? So it will give you, you have the dried granules from the previous section, you put them in the blender and blend for a particular period of time. Again, everything must be indicated. And then you have also the SOP for lubrication. Remember, we had indicated that for lubricants, we are trying as much as possible for this to be the last process. And so you'll be also given the instructions. Lubricants will also have their own mesh screen, which you are going to use to screen them. And then how you are going to add the lubricant to the contents or to the other powder blends which were prepared, or granules prepared before screening of the lubricant. So once you have then undertaken all these steps, you started from dispensing. From dispensing, you went on to blend. If you needed milling and screening, you did the milling and screening. If you needed to produce granules, you went on to produce the granules. If you then needed to reduce the particle size of those granules, you went on to do that. And if you then needed to add a lubricant, you've gone on to add a lubricant. And once you add the lubricant, we know that the lubricant is the last excipient that is added to the granules or the powder blend. Once you have reached that stage, then it means you are now ready to go and start the process of compression. Compression is now a stage where you are now required to put the powders or granules together. You compress them to form compacts, which we refer to as tablets. So that's the next stage. I see it's 8 hours. Do you guys have another lecture?